these charged particles could hurtle right through a spaceship and penetrate astronauts like tiny ballistic missiles, ripping apart DNA molecules and even killing cells.
A high-energy cosmic ray, if it interacts with human tissue, can do damage to the DNA in that tissue and lead to a disruption of the cell, maybe leading to cancer.
And cosmic rays may not only threaten space travelers. Every second, cosmic rays bombard our Earth's atmosphere. Some even penetrate all the way through and rain down on our planet. The key to cosmic rays' transformational energy is speed.
So even if it has really tiny mass, like most cosmic rays, they've got enormous velocity. So their kinetic energy can be really, really large.
When they strike the Earth's atmosphere, they collide with molecules, mainly oxygen and nitrogen. This produces a storm of energy in the form of ultraviolet radiation that cascades down on our planet.
Those cosmic rays are coming from outer space all the time, 24 hours a day, just impinging upon the outer atmosphere and running into the air molecules, and then producing showers of particles that we can detect here on the surface of the Earth.
Fortunately for us, one original ultra-high energy cosmic ray spreads its energy out to millions or even billions of particles. So its energy, originally in the form of X-rays and gamma rays, is so dissipated that it's no longer harmful to humans. However, these cosmic rays could cut off your cell phone conversation.
These air showers, as they're called, which are produced by the cosmic rays hitting the outer atmosphere, those could affect electronics here on the ground. Our computers and cell phones and other devices that we use every day are becoming more and more delicate as we miniaturize our circuitry. And that actually makes it much more sensitive to being disrupted by cosmic rays.
In every corner of the universe, we witness the destructive nature of energy in motion. Yet here on Earth, we generate a unique form of energy that comes from the creation of our solar system. Since the beginning of time, energy has been the universe's long-standing magic act, constantly changing from one form to another. One unique type of extreme energy is the legacy of our solar system's creation. Geothermal energy comes from the heat created in the Earth's rocky core, which exists about 4,000 miles below the surface.
Our solar system was first formed about 4.5 billion years ago when a cloud of gas and dust condensed to form the sun and all of the planets. A small fraction of that gas and dust consists of radioactive elements like uranium-238 and thorium. When the Earth condensed, some of those radioactive elements got collected into our Earth's interior. As those elements slowly decay over billions of years, they heat up the interior of the Earth. We can access this heat energy as geothermal energy.
Some areas of the Earth's surface allow this geothermal energy to seep through, such as near plate tectonic boundaries, volcanoes, and geysers.
Geothermal energy can be tapped near plate tectonic boundaries where this hot stuff comes up, produced by exploding stars long ago that are radioactive and release their energy over timescales of billions of years.
Geothermal plants around the world harness heat energy from superheated reservoirs to create electrical energy. Here's how it works. High-temperature, high-pressure water is brought to the surface, where it enters a low-pressure chamber and flashes into steam. The pressure created by this steam is channeled through a turbine, which spins to generate electrical power. Once the steam has exited the turbine, it is either released into the atmosphere as water vapor, or it cools back into liquid water and is injected back underground.
In almost all cases until recently, geothermal power plants have been either near plate boundaries or hot spots, weak spots in the Earth's crust through which the hot magma can come. So since most of the Earth's surface is not near a plate boundary, it's been relatively difficult to tap into geothermal energy.
The best concentration and quality of geothermal energy exists where there are high levels of tectonic and volcanic activity, like the Ring of Fire, which circles the Pacific Ocean. But excavating close to plate boundaries is tricky.
To get a lot of consumer energy out of the geothermal energy of the Earth really requires digging quite deep to where the temperatures are high enough that you get a lot of energy out. The technological challenges for extracting geothermal energy for consumer use are huge. You either need to harness a volcano or drill down very, very deep into the Earth, or cap the geysers of Yellowstone.
But this type of thermal energy may not be exclusive to planet Earth. Io, one of Jupiter's 4 main moons, has active volcanism like Earth. But the thermal energy from its core is produced not through the decay of radioactive elements, but rather through tidal heating.
Io has an elliptical orbit around Jupiter, so sometimes it's closer to Jupiter than at other times. When it's closer to Jupiter, the tidal stretching of Io is greater than when it's farther from Jupiter. So as it orbits Jupiter, Io sort of squishes back and forth. That gives rise to a lot of rubbing of the interior rocks, and they then release energy. The interior gets hot. Magma flows to the surface, and you see a bunch of erupting volcanoes. So that can be thought of as a geothermal energy.
We certainly know that the inside of Jupiter's moon Io is molten because we see volcanoes there, and that is the equivalent of geothermal. I say equivalent because geo means Earth, so strictly speaking, geothermal is Earth's interior energy.
Planet Jupiter may not have a molten core like its moon Io, but the gas giant's hot interior generates another form of extreme energy, wind.
The giant planets, Jupiter and Saturn, have very windy atmospheres. They are very stormy, not just because of heat from the sun, but in fact largely because of heat generated on the inside. Their interior parts are still contracting, releasing gravitational energy and converting it into energy of motion of the atmosphere, winds and storms. This is another example of the conversion of one form of energy into another. Some of the winds on the giant planets can travel at immense speeds, 600 or even 700 miles per hour. Now, most of them are only a few hundred miles per hour, which still is big compared to even big storms on Earth. But the fastest storms can travel at 600 or 700 miles per hour. That's really fast.
Earth also benefits from wind energy, but its source doesn't come from its core, but rather directly from space.
The source of energy that we see in winds on Earth is really solar heating. The sun heats different parts of the atmosphere by different amounts, and that causes imbalances that allow the air to flow. That's wind energy, mechanical energy coming from the sun's electromagnetic energy. That wind energy can then be used to drive a turbine, converting it into electrical energy that lights our cities.
Energy has propelled the evolution of the universe since its birth over 13 billion years ago. But now, science has discovered a mysterious type of energy that just may be the cosmic Grim Reaper.